be 12, 13, 14, 15. There is no 16 on my paper. How did you have 16? Did I miss it? Oh, there it is. Oh, yeah. Multiplication, correct?
Yes.
You just have to remember, anytime you multiply whatever this is, rational expressions or something like that, you can't just pull out things unless they're factors. So the only way to anything in this to cross off is to factor them out. So you're going to need to do that. Where, I don't know. What can you take out of this one? A what? Why not? So yeah, take a y out and you're left with what? 4x plus 1. The only way that'll cross off is if you get a 4x plus 1 somewhere else. Oh look, what do you get up here? What can you take out? X and a y, which leaves you with a 4x plus 1. So now what'll cross off? Well, let's see. How about this bad boy? 4x plus 1, 4x plus 1. Here's a y. There's a y. Everywhere's a y. Here's an x. There's an x. The only thing you're left with, it looks like, is 9/15, which reduces by 3 to 5/3. Schwartz.
Did you 5?
Maybe. Is that on this page? No. Separated. Oh, you're gonna test my memory here. Distance between those points. I would suppose you'd want to know the distance formula, which is distance equals, this is the square root, I believe, of x sub 2 minus x sub 1 squared minus, yes, plus y sub 2 minus y sub 1 squared. Who asked me that one? Did you write that down here?
Yeah.
Do you have that? And it doesn't matter which ones you call which ones, but just for whatever's sake, let's call these the ones. Call those the twos. Sub 2s. So x sub 2 is 1. And again, I always put these parentheses, I just find it helpful. Some of you don't. You get stuff wrong, and it serves you right mostly. X sub 2 minus x sub 1, which is 6. Y sub 2 is negative 4 minus y sub 1, which is, uh-oh, did I do that wrong? Yes. No. X sub 2 is 1. And y sub 2 is y sub 1, y sub 2, y sub 1 is negative 4. Did I get those in the right spots? You would tell me what you. Schwartz, did that look right to you? That's
Wait. Is it x sub 2 on the left?
No, I put 1 on the left.
No.
Am I wrong? Am I wrong or am I wrong? Anyway, so here's what it would look like. 1 minus 6 is negative 5 squared plus, over here we have what? 1 minus a negative 4, which is actually 1 plus 4, which is what? 5 squared, square root of. I don't know what kind of pressure this is. I want this on my video. If I get this wrong, it's terrible. What's 5? Negative 5 times negative 5 is 25. 5 times 5 is 25. Add those together, it's the square root of 50. And the square root of 50 breaks down to square root of 25 times the square root of 2, and that is 5. So the distance is 5 square roots of 2, which is close to how far? Square root of 2 is what? 1 point something. 1 point what? 1.3, 1.2, 1.1?
Can we just use Pythagorean theorem?
Well, that's what this actually is. When you do this, you're actually, that is really what that is. Just written out in formula form. Yes, you could. You would have got that same thing. Did you?
Yeah.
It just mattered, you just have to actually graph it then and look at the stuff there.
No, this one has to back.
Sure, if you feel that need, although I know, I'll make sure you know that it's just. Logan,
Most 18, 19, and 20.
18, 19, and 20. 18 is x is greater than 3, open circle at 3 going to the right. 19 is an open circle at negative 3 going to a closed circle at positive 2. That means x is greater than negative 3 and less than or equal to 2. And number 20, x is less than 3, or x is less than negative 3, or x is greater than 3. Open circle at negative 3 going left, closed circle at 3 going to the right. Wilma,
Can you do 4?
I don't want to. Is it hard? No.
I'm sure it would
Did you do the distributive property?
be more.
Would you have to do the distributive property? Yeah, probably. That times that, Madison, is square root of 20. This times that is square root of 12. Now you just need to simplify them. So square root of 20 is the square root of 4 times the square root of 5, and the square root of 4 is 2. So you have 2 square roots of 5 there. This is the square root of 4 times the square root of 3, and the square root of 4 again is 2. Every time I've done that, it was 2. And you can't combine those because they're not like terms. You have to have equal square root things to put those together. Hence, it stays just that. I feel good about this test, don't you? Which one did you get wrong? Nothing?
Wait, do 17.
Huh?
17.
You want me to do 17?
Yeah.
Is it a hard one?
It's the
Is that this one?
thingy plus the thing.
Or is that this? Am I wrong, man? It's what plus the what?
It's the fraction of stuff in it.
Wait, this one here? Oh, yeah. If you did this on tried to do that in a square, I would strongly recommend you using ginormous. I'd use a whole piece of paper. Wait, did I do that for you? Who got this right without my help? Really? Huh. First thing you have to do with fractions is do what with them? Write them up and down. Just go along with it here. So at least you got that far, right? Sure, why not? And then what has to happen? Grace Watson, in order to find the least common multiple of the denominator or the common denominator, you have to start by factoring the bottom to try to figure that out. This one you can take a 2 out, and you're left with x minus 3. This one, hopefully at some point in your mathematical careers, you can recognize that when it's a binomial that has 2 square things and a minus sign, and that it is factorable into x minus 3 times x plus 3. And then your common denominator would be, Ryan Connor,
2x minus 3, x plus 3.
yeah, you take the group that has the most of each factor. This one has a 2, so it's a 2. They both have 1 x minus 3, so you just take 1 x minus 3, and this one has an x plus 3, so you have an x plus 3. So 2 x minus 3, x plus 3. Stop me if you didn't catch that. That is your common denominator. And then you do the whole arrow thing that I made you do back in 5th grade. How do you go from this to this? What are you missing? You are missing this x plus 3. So I have to multiply the top by an x plus 3. which is not as easy as it sounds because it's a binomial times a binomial. We use our favorite thing of FOIL, and FOIL gives us Brook-Kala, x squared plus x minus 6. Do I have to do that out, or can you just pick that up from that? First outer and last? You'd stop me there if I'm going too fast, won't you? Sometimes your awkward silence is deafening. What am I missing from the top? Cameron? What am I missing? To go from this to this, I'm missing the
X minus, or the 2.
2. So I multiplied this by 2, so I have to multiply the top by 2. And 3x squared times 2 should be pretty easy for you. It is 6x squared. Voila. Everybody's happy? So you keep your same denominator when you add the fractions together, so you know the bottom. You know the bottom is going to be this. The bottom is going to be 2 times x minus 3 times x plus 3. The top, you have to add the tops together, and the only thing that combines are the x squared terms. 6x squared and 1x squared is 7x squared plus x minus 6. Now you do have to see if this could be simplified. If you happen to get an x minus 3 or an x plus 3 on top, or a 2, but when you factor this, you end up with 7, it ends up being, I think, 7x minus 6 times x plus 1. That doesn't break out with anything here, so you just can leave it like this. Or you could have left it like that on top. But the book left it like that. And you look very intelligent when you do a problem like that because of all the scratching stuff. Watson?
Did you do number 11?
Write down it for it. Over here. There you go. Oh yeah. You know, I was wondering about number 11 there. Because as I looked at it, I would think it would be a
System.
is it system of equations?
I actually don't know.
Who
No,
actually-
I looked it up on the
Who
book.
did this one? I was just curious as to how you did it, because I could explain it maybe one or two ways, but I don't remember doing a problem like this, so it was slightly confusing. Maggie, how did you do it? Kayleen, how did you do it?
There is a problem in the book.
That's a very good way to look at it. But I don't remember talking about this, so I'm going to say this did not fit into the inverse variation stuff that we used to talk about. This one, and I again looking in the book, basically said this: you have to take their two rates, how long it takes them to do something, and add it into the figure out how many jobs they were doing. Which means this. How fast could Ann do this? And I find it hard to believe we talk about this. What was Ann's rate? If it takes her 3 hours to rake a yard, it takes her 3 hours. 3 hours. 3 hours. 3 times what number is one job done? This is a time times rate equals how many jobs you get done. What is her rate? How fast is she doing this? If I was solving for the letter N, what would I do? We should have had a whole section on this first. What is a Brooke column? Yeah, Ann can do 1/3 of a job per hour. That's her rate. If it takes her 3 hours to do the whole thing, for every hour it takes, she does 1/3 of it every hour. That's how fast she's working. Correct? With that same thing in mind, Linda, if she does it in 2 hours, how fast is she working? Using that same thought here. Ryan Connor, how much of a job does she do every hour? Half of a job per hour. And then putting it together, how many jobs are they doing? Are they raking 2 lawns, 1 yard, 6 yards, 12 yards? David? 1 yard. So you put their rates together, we want to get 1 yard done. So this girl here working at 1/3 of a job per hour, plus this other girl working at 1/2 of a job per hour, needs to get 1 job done. And then there, that would be the adding up these things. What's your common denominator? What's 1/3 plus 1/2? You can combine these. 1/3 plus 1/2. Common denominator is 6. This is what? 3/6 plus 2/6. Is it 5/6? So 5/6 times h equals 1. And how do you solve that equation for the letter h? How many hours it'll take them? Flip and multiply like we always have. And that's where the 6 gets from. Maybe I'll make this extra cut, even though it's very easy. And it wouldn't matter how many people you do that same thing. You always put this over under 1. And that's what the note I write to myself. Whatever time they give you, you put it under 1. You're going to add them together. It's going to equal 1 job done. If they were doing 6 jobs, you could put a 6 there. If they're doing 12 jobs, you could put 12 there. But don't do 1 job. These are work problems. I can't believe it didn't come up in any of the stuff that we've done so far. Schwartz. Can I do one? Didn't I do this one on the board?
Yeah, so,
What's that?
I'm still confused. Can you help me?
So that's why you're confused. One more time on number 1. The area of a rectangular carpet is 54 square feet. So you start off with this. The area of this is 54 feet squared. What are their sides? How long is this? And how long is this? Well, we don't know, but we know how they compare. The length is 3 feet more than the width. So if you make the width x, what does the length have to be? What's 3 feet more than x? X plus 3. Now find area of a rectangle. Area equals length times width. I know all of those things. I know the area is 54. And I know the length is, well, length and width are x times x plus 3. Those are the 2 things that multiply together. If you do the multiplication here, Schwartz, you get what? X times x is x squared, and 3 times x is, and that equals 54. And then you just need to solve that. How do you solve such things? Set it equal to 0, subtract your 54 over there, so you get x squared plus 3x minus 54. Why minus? Because I had to subtract it over there, and that all equals 0. And you can solve that many different ways. Probably the easiest way is to do it by factoring what times what gives me this trinomial. X and what times what gives you 54 when added together gives you 3. Negative 6 and positive 9. Now those are not, don't get in your head that those are going to be the 2 answers, because they may not be. Okay, because you have to solve this. What does this one end up being? X minus what number gives you, x minus, what number minus 6 gives you 0? Positive 6. What number subtracted from 9 or added to 9 gives you that? Negative 9. Remember, distances can only be positive values. So one answer is 6, and the other one is 6 plus 3, which is 9. And I don't know, maybe you always do get whatever this is. Let me look and see. I'm going to look at tomorrow's problem and see if that works. What is chapter 20B? Yeah, I'm right in the middle of something here. 20B. Maybe it works. Maybe this is all just water under the bridge. Ryan,
From 10.
did we not do 10 already? Is it on this page or is it on the track one?
It's on the first page. I
On the
think
first
it's
page?
alive.
Bottom left?
I know that's
No, not factoring by grouping, is it? Alright. Only way to factor a 4-term thing, Ryan, is do it by grouping. What can you take out of the first one?
24.
So you look at it like this. You're gonna group it like this. Looks like there's stuff you can take out, and you're gonna group it like this. So what'd you take out?
24A cubed.
24a cubed. If you take that out, you're left with a b plus 1. You have to get that 1 in there, because if you don't put the 1 there, that whole term goes away. So you're actually dividing that up. Did you get the b plus 1?
Yeah.
Over here, okay, you want your first term to be positive, so you're going to take a negative out. Negative what? Looks like 18a squared, right?
Yep.
You take a negative 18a squared out. What times this gives you that? B. What times this gives you that? Plus 1. Okay? And then, when you get to that point, if as long as you have same things in parentheses, you can take just the 1b plus 1, and the other parentheses comes from the 24a cubed minus the 18a squared. Now, this is where you would shun the teacher. For what reason, children? I have broken the fundamental rule of factoring, which is what? And I didn't realize it until this point, because that doesn't look quite right. Somebody, what fundamental rule? I should be slapped. Because I did not do the fundamental rule. What is it? Who knows it and just doesn't want to say it to make me feel bad? Fritzl, you know what it is? What is the first thing you do when you factor things? First thing you do when you factor things that I did not do. Well, yeah. The first thing I should have done was looked at all 4 of these and said, is there a common factor that they have? In which case there was a squared. Now, I recognize it here because both of these have an a squared out of it.
Wait, 6.
And a 6. A 6 and an a squared. So this is not factored all the way because I can take a 6 and an a squared out of both of those. So I put my 6a squared here. I end up with 4a minus 3. And the b plus 1 just stays as it is. And this would be factored all the way. This would not have been. It is factored somewhat, but not all the way. Again, inside I am devastated that that happened to me. I apologize to you, but I told you I got a C in algebra 1, so you can't expect any more than that from me. Second. How many people did it? Who did it right the first time? Did you factor the 6a squared out right away? Maggie, did you? That helps. Pouring salt in an open wound, if you will. Has anybody ever done that just to see what it's like? If you ever get a chance, do it just to see, because every time. Have you ever said it?
It's what?
Putting salt on an open wound. I don't know. I've never done it, but people say it, so I think you should try it. The next time you cut yourself bad, just get salt and say, I want to try it just so when I say it, I know it's
Well, she doesn't sound like help it. It's like help it naturally work.
rubbing alcohol hurts.
I had that.
I thought like
That
salt
is-
was really
I've done a lot of things.
So that's how from jujitsu.
Yeah.
Alex!
For number 9 is negative x minus 4.
For number 9 is negative x minus 4.
And x plus 3 is equals.
Hold on, let me talk about that as well. For problem number 9, let me just give you a little helpful hint for you the rest of your future mathematical careers. Anytime you factor something, it's never good to have a negative first term. So when you do that, not that you can't do it because it can be done, but to really make your life easier, first thing you want to do is change those all to their opposites by factoring out a -1, or just a negative, it doesn't really matter, which just changes the sign of everything inside, because that just is easier to think about than having a negative in there. So when you factor this, you should have got -1 times, it looks like x plus 4, x minus 3. Now, that is the exact same thing as if you would take this negative to either one of those parentheses. So this could also be known as, you could take a negative there and make it -x minus 4 times x minus 3. That would be the same exact thing. Or you could put the negative with the second parenthesis, get your x plus 4, and then make this -x plus 3. All three of these, this, and this, really are the same thing. Generally speaking, though, you really want, to keep people from being way confused, this is the accepted divisible one that you would actually use. These would all technically be right. Couldn't mark them wrong because it's actually whatever, but this really would be the way you want to do it. Always want your first term in anything. Little man. Who?
What if I don't know?
12? Is it a hard one?
It's just finding axis of symmetry.
Oh, the axis of symmetry. Do you have the formula written down for the axis of symmetry? What is it, Madison? Over 2a. Negative b over 2a. A is -3. B is -6. You don't need the c. So again, please use parentheses because that's probably where -b over 2a. B is -6. A is -3. -6 is +6. 2 times -3 is -6. And 6 over -6 is a -1. That's all you had to do for that? X is -1 at the x axis.
Did you do 18?
Could I do 18? I find it surprising. Yeah. This really kind of goes back to your general symmetry kind of math there. Stritzel, what did you do first?
What did I do?
Oh, you could look at it and tell me. What would you do first?
Yeah,
Distributive property?
yeah,
So you're gonna take 3 times both of those things, right? You got 3x minus 12. A, what's this give you?
-8x,
Yes, and
10.
I'll give you 10. Then your next step would be to simplify what you can on each side here. What can I put together there?
3x minus x.
Which is,
2x.
what can I put on the other side?
Plus 10. And 8.
Which is,
18.
yeah, so I get -8x plus 18. Now once you do that, you can move stuff around by adding and subtracting, which means I would move what, where, and why, when, and how. What's that?
Add 12.
Okay, add 12, do the opposite, add 12 to 18, and it is 30. And then
Subtract 2x.
negative. Why? Well, 2 reasons for sure. You would put your numbers on that side, so the x's have to go on the side, and with inequalities, you need to put them on the left side. So you shouldn't subtract 2x, you should
Add 8x.
add 8x. Does my sign change with that or not? Huh?
No.
It does not. It only changes when you do that by multiplying or dividing. You can add and subtract stuff all day long across, it doesn't change the sign. And then your last thing is divide by 10, divide by 10, so x is greater than 3. 19 while I'm there or no? Alright. This one again, first thing you do is simplify the different parts. So you can put together these two x terms. You get -4 less than 2x and x is 3x plus 5. And then don't forget, this is like two equations put together, so you have to do it to both sides. I want to get x by itself, so I subtract 5 from both of these things. And that gives me a -9. And this gives me a +6. And then when I divide to get the x by itself, divide the 3. Again, you have to do that to both parts. So you end up with a -3, the less than sign x, less than or equal to 2. And then when you graph it, it is a -3 to a 2. Open circle because there's no equal sign. It is now. Close circle there. Color in. Kind of exciting. Alex?
Number 15.
15. Oh, yeah, I like that one. We didn't do a lot of this, did we? It's been a while. Just like a normal division thing. Actually, there's two ways to do it. Does anybody do it by factoring? You just cross them out. It's kind of a, if you were given this problem on a test, other than what we've already talked about, what you kind of have to see is this. Okay, because this is going to work out evenly, it is this divided by that, so it's actually this, x squared minus 10x plus 25 all over x minus 5. So you can't get anything to cross off unless you have an x minus 5 on top. Well, so when I factor this, guess what I do get? This is x minus 5 times x minus 5. It's 5 times 5 gives you 25, add it together gives you minus 10. And then bam, we cross this off here. And that's where the x minus 5 comes from. But you cannot be guaranteed that that's going to work out tomorrow, so you really need to know how to do it the long division way. Which we did do, did we not?
Yeah, but
Yeah, but what?
you did it once and then you didn't have homework, then that's it.
So, review of that, because you will have to do this eventually in all of your math classes. Write this out like a division problem. X squared minus 10x plus 25. Yeah, we should have reinforced this. And then it's just like division. What times x gives you x squared? X. And then you have to multiply, divide, multiply, subtract, bring down. Does math seem boring? Remember that was the whole. You don't have to answer that now, but you can wait till the privacy of your own home. X times x, multiply, x times x gives you x squared. X times -5 is -5x. Subtract means you change their signs to their opposites. This goes away, which is what you wanted. When you subtract this or put those together, you get -5x plus 25. And you start all over again. What times x gives you -5x? -5. You get -5x. Plus 25, change their signs, and everything drops away and goes away, so you have this. If it didn't, you'd have a remainder and you put it over top of that, if you remember that from back in the day. Does tomorrow's workout, you ask? I can't tell you that. What problem was it? I can't tell you that. Somebody got time for that. Maybe I'll change it. You'll make an extra credit probably. Watson. Like it's not difficult. Is that here? Is it on the first page? On this page, on my first page, yes it is. Number 7, as best I know how. Oh, I have really? You graph this?
They're one-handed?
Just make sure your quadratic is x squared plus 0x minus 9 equals 0. Remember, a is 1, b is 0, c is -9. Axis of symmetry, negative b over 2a. Well, b is 0, so you're going to get 0, so the axis has to be here. And you know that the letter c is the y-intercept where it crosses the y-axis, so you know this crosses at -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then once you do that, you kind of have to just put in random points. For example, if you put x is 1, 1 squared is 1, 1 minus 9 is -8. So at 1, you have a point at -8, and you have a point over here. At 2, 2 squared is 4, 4 minus 9 is -5. So we get a point like right here. And at 3, lo and behold, 3 squared is 9, 9 minus 9 is 0. Well, that tells you right there what your answers are. The roots, if you will. And somebody saying, can you use a calculator? Only if it didn't work out. Does it work out, you ask? I can't tell you that. They make this so easy. We're writing this one. That's that. Can you use a calculator? Wait, didn't I already say that? Did I already answer that?
I did.
And I said no, didn't I? For the graphing of the thing there? I don't know. It's so hard. Become fundamentally reliable on a piece of solid state. Do you guys all have the same question? Really? Did I do something wrong? Usually that's what happens when people in the back of the all 4 of you? You are ganging up on me now. Brooke, what's 13?
It's the triangle that it says round to the nearest decimal.
Oh, obviously not. But what?
13.
Is that what you're gonna ask me?
Oh.
So you all have the same question there?
I thought about that too.
Wait, let me see it.
That's not the right slide.
Is it this one?
No, it's
No,
behind,
it's
it's behind your tools. Go back to page, no, the other page.
There's nothing behind my tools.
No,
You're
yes there
using the
is.
wrong slider.
Go back to the other page,
Thanks.
other page. Yeah. That slide
I'm
up.
seeing the wrong slider. There's nothing there.
Yeah.
You think this is easy? Wait, find the side length to the nearest tenth. Yeah, that's fine. Is that good there? You can use the calculator as long as on the graphing thing, you write me down the axis of symmetry. Whatever ones that tells you to graph the parabolas. Show me the work of the axis of symmetry where you go a equals negative b over 2a in the quadratic equation. That would be a good one. Speed?
Can you do number 13?
No. Just write it down, a squared plus b squared equals c squared.
Yeah.
Which one don't you know? In this case it happened to be t squared, right? And it doesn't matter what you call the other two. 3 squared plus 5 squared equals t squared. 9 plus 25 equals t squared. 34 equals t squared. And then without a calculator, yeah, first thing you narrow it down, between what 2 whole numbers is it? Well, t is the square root of 34, so you know it has to be between 5 and 6, correct? Because 6 would be 36. What would be your best guess? If you didn't know and I don't remember what the answer is, it's got to be closer to 6. So I would sit here and go 6.1 times 6.1. Well, that's going to be too low. Let's pick a different one. How about 6.2? No, it's got to be 5.8. 5.8. Imagine what that is. What, 64, 4, 6. Do I have to keep this up? I don't really want to do this. 46, 0, 40, 4, 24, 29. 6, 3. Oh, look at that, 33.64. That's not bad. That's too low, so my only other choice would be what, 5.9? Which is what, 81, 8, 45, 53, 0, 45, 29, 1, 8, 4, 3, 3.84. I would have to go with this one. Is it?
Yeah.
But yes, wait, are you using a calculator just putting the square root of 34 in there?
Yeah.
Lazy is all I can say. But you'll fit in well at public school. Will, man? I already did 14 twice. Ah. Alright, man, so what's the first thing you gotta do? What do we call that? Sound mathematical. Madison? Madison? What? Isolate the absolute value sign. How do you do that? Subtract 4 equals -2, 3 times the absolute value of x over 6 equals -2. How do I get the absolute value isolated now? Multiply both sides by 6. I get -12. 3 times the absolute value of x equals -12. Now, Madison, divide by 3, divide by 3. So now the absolute value of x equals -4. And it's at this point you say, uh-oh. What's the uh-oh? What does absolute value signs do?
Change it to
Absolute value changes everything to a positive. There is absolutely nothing you can put in this absolute value sign that's going to give you a negative over there. This is no solution, you can't do it. You cannot get an absolute value of a negative number. So at that point you can just stop. Otherwise, what you would have done was taken the absolute value, taken what it equaled, and then done the same thing with its opposite. But you can't, because no matter what I put in the absolute value sign, I'm going to get a positive there. So, big.
For that problem, can we also multiply the 6 over 3?
Yeah, you could have flipped. At this point here, this, by the way, 3 over 6 absolute value of x is the same thing as 3/6 times the absolute value of x. And Maggie said, could I just multiply by 6/3? Yes, you could. You'll get the same thing. Is that what you're asking? Not many of these left, kids. It's starting to wax nostalgic. Or wane nostalgic. Speech.
Is it okay if number 20 guided plus 3 -3.8?
Hold on a sec. You said which one?
20
If you have what?
positive -3.8.
Okay, here's what you have to have in your notes on this one, and I believe we talked about this. Absolute value signs with inequalities get a little goofy here. If it's greater than, is it an or problem or is it an and problem? And I ask again because I don't really remember, but I can think about it. Greater than or and. So if you see a greater than sign, it's going to be an or problem, and your arrows are going to shoot off in opposite directions. They have to. If it is a less than sign, it is an and problem, which means your thing's going to come together and converge in the middle. So when you see this right away, you know that they can't both be going the same way. Remember, you solve this just like a regular thing. You multiply both sides by 3. So the absolute value of x has to be greater than 3. And the way that that works is this. you take the way the absolute value signs, keep everything the same, x has to be greater than 3, flip the sign, change it to its negative, x also has to be less than negative 3. So that's this right here. At 3, it goes off in that direction. At negative 3, it goes off in this direction. Them's would be notes that I would take for myself on that one. David, how you feel about this?
Good.
A lot of useless mathematics, isn't it? Yeah. Never again will you come upon this. That's when you want to try to go to college. Then maybe, just maybe. Of course. What? Claire, did you sing along? Stritzel,
What'd you do?
number 3. I would love to. Caitlin, what do you think you should do for number 3? Are you completely no idea or?
Find the common
No, that's only when you add or subtract fractions. This is a fraction divided by a fraction. There's no addition or subtraction signs there. This means this. Okay, look, it is m over x divided by n over m plus x. It's a division problem. And believe it or not, we've done problems like this since end of 5th grade. How do you divide by a fraction? You? Right, so you're just going to take this second fraction, flip it over. Oh, they left a message too.
Maybe it's Claire.
Maybe. And then you look to see, can you cross something off? Caitlin?
The x's.
I cannot cross the x's off. Why can I not cross the x's off? Because this is part of an addition. You can only cross them off when they're factors. The only way this would ever cross off with anything is if there was another m plus x in parentheses somewhere else. Okay, so none of this crosses off, the m's and the n's, and it just ends up being m times m plus x over x times n. Nothing simplifies any more than that. So if you wanted to multiply the m times the m plus x and get m squared plus xm, then by all means. Does that help?
Yeah.
No addition subtraction signs here. Not common denominator. This is just straight up whatever. Hitting the stop button.